Good morning, dear students. So, this is the part 2 of chapter 13. So, today we are going to start a new topic, that is chemical effects of electric current. So, we try to understand what is electric current, how it passes through in a circuit, and also we try to understand how to find out whether a particular matter that may be in solid state or liquid state is a conductor or not. That means through which electricity can pass through or not by a simple experiment using battery and a simple bulb. If the bulb glows, then the electric current passes through it, that is, it is a conductor. If not, then electric current does not pass through it. So the aim here in this activity 6 is to show that water conducts electricity. In the previous class, we have already discussed that pure water is an insulator. Now, what are the material required here? Two carbon rods called electrodes. These rods are used to carry the electricity into the liquid. So here you can see these are the two carbon rods. Okay. Now, through this carbon rod, electricity passes through the water. You can also take two iron nails in place of carbon rods. Here, in case of carbon rod, it can be replaced with iron nails or any other conducting material or conducting medium. Now, what are the procedure? Attach the carbon rod to each of the terminal of a battery with the help of wires. Dip the rod in water contained in a beaker. Add a teaspoonful of salt or a few drops of lemon juice to water to make it more conducting. Wait for 3 to 4 minutes. So here you need to attach wires over here and dip the conducting material into the medium. Okay. Now, here what you are going to observe, you will see bubbles of gases coming from the water near the electrode. So this is a battery. It is connected with the two rods, maybe iron rod or carbon rod. So here you can see the bubbles are forming after a specific period of time, maybe 2 or 3 minutes. Okay, so this is the water here. This is the water. Now, what are the conclusions here? These bubbles of gases are of hydrogen and oxygen. We conclude that electric current breaks up water into constituent gases, that is hydrogen and oxygen. So if there is no reaction, had there been no reaction, the gases or the bubbles would not have formed. So here, as we know that water is made up of two fundamental particles, that is two hydrogen and one oxygen. So here bubbles are forming. Okay, over here hydrogen and over here oxygen. Now this is the next activity. Here our aim is to study the chemical effect of current. Okay. What are the material required? First one is two copper plates. These are the two copper plates. Copper sulfate solution. This one is copper sulfate solution. Okay, inside the container. Battery. This is battery. Beaker, copper wire. This one is beaker, okay, container, and this is the copper wire. Now you need to connect the battery and the copper plates through copper wire as it is shown in the figure. So this one is negative terminal, this one is positive terminal. So the procedure, how you are going to connect it. What is the observation? You will see a fresh shiny reddish deposit of copper on the negative copper plate. This is a negative copper plate. From here, as you can see, this is looking little bit black and white type. This is looking little bit colorful type. So here reddish brown color will be deposited right over here. Here black color will become black. So you will see a fresh shiny reddish deposit of copper on the negative copper plate. This is the negative copper plate. weight the plates, you will notice that the negative plate weighs more after passing current. Where does the copper come from? So if initially when we took the plate, the two plates were identical, that means having same shape and same mass. Now after this experiment, if you are going to measure the weight of these two copper plates, this copper plate of this side is the weight of this plate is more compared to this one. Earlier the weight was same, now the weight differs. So why there is a change in the weight? So the copper deposit on the negative plate came from copper sulfate solution. So from the copper sulfate solution, some amount of copper came and deposited right over here. So its weight increases, its mass increases. Thus electric current breaks of copper sulfate solution also. So from here we prove that the electric current that passes through this wire into the system, it breaks up copper sulfate solution also, and here the uh, negatively charged plate attracts the copper, and copper from the copper sulfate solution get deposited right over there. Thus, when electric current is passed through certain liquids or solutions that conduct electricity, chemical changes occur. Okay, this is called the chemical effect of electric current. So here, from this activity, we saw that what is chemical effect of electric current. That means, in first activity, when electric current passes through, water gets divided into hydrogen and oxygen gases. In second activity, when electric current passes through the copper solution, the copper gets deposited into the negative terminal. So these are the chemical effects of electric current. The chemical decomposition of a liquid or solution while passing an electric current is called electrolysis. So what is the meaning of electrolysis? This word is very important. So the chemical deposition of liquid or solution while passing an electric current. Okay. So in the second experiment we saw that when we pass electric current, the chemical from copper sulfate solution, that is copper, started depositing in the negative terminal. Okay. So the chemical deposition of a liquid or solution while passing an electric current. So this chemical that deposits in one terminal, that is called electrolysis. The whole process is called electrolysis. The liquid or solution that breaks up during electrolysis is called electrolyte. The liquid here, what is the liquid? Here we took in this activity, that is activity 7, copper sulfate solution. This is the liquid. So this liquid is called electrolyte. Okay, the liquid, this one copper sulfate solution, this is called electrolyte. Electrolysis means the chemical reaction that is happening, the whole process. Electrolyte means the solution that we are taking. So don't get confused between these two terms, although these two these two looks similar, but they do have different meaning. So, an electrolyte, when dissolved in water or when melted, produces ion. So, whenever we dissolve an electrolyte in water, okay, or when melted, it produces ion. So, when we are dissolving electrolyte into water or whenever we are melting it, it produces ion. That means electrolyte generally formed after having some chemical bond. So then that bond, due to that bond, it produces ions. These ions are free to move throughout the solution. So throughout the solution, the ions randomly move here and there. The positive charged ion are called cation. This is also very important. Positive cation means positive charged ions. The negatively charged ion are anion. Anion means negatively charged ion. Remember, positively charged ion means cation, negatively charged ion means anion. You must have found that kerosene does not conduct electricity. Hence, it is a non-electrolyte. Okay. So, electrolyte means it has to conduct electricity. Electricity has to pass through it. That is called electrolyte. So as kerosene does not conduct electricity, it is a non-electrolyte. Okay. So what are electrolytes? Liquid which conduct electricity are called electrolytes. It should be in liquid form. Any liquid through which electricity can pass through is called electrolyte. Okay. Means it you can consider it as a conductor. Conductor is something through which electricity can pass. So if it is in the form of liquid which conduct electricity, that is called electrolytes. Now this is our next activity, that is activity 8. It is also very important. Here this is a potato, okay, which is being cut off half. This is the half of it. Now this is a compass box. Whenever this electric current passes over it, it deflects when it is kept nearby a wire in which electric current is passing through. And this is the battery. What is the aim of this experiment or aim of this activity? To test whether some fruits or vegetables also conduct electricity or not. Because we know that the fruit and vegetable, they contains water molecules, and through water electricity can pass. So what are the material required? The potato, copper wire, battery. Procedure, now connect these three. Observation, you will observe that a greenish blue spot on potato around one wire, whereas no colored spot will be seen around the wire, around the other wire. So there are two wires. Around one wire, a greenish blue color will appear. Another wire, there is no change in the vicinity. The greenish blue spot will be found around the wire which is connected to the positive terminal of the battery. So this is the positive terminal of the battery. This is the negative terminal of the battery. If you do this experiment, here you can find out this part will become little bit green. You can do this experiment on your own, because here you do not require this one, because it might not be with you, the magnetic compass. So you can directly connect the battery with the potato till it will change its color into a little bit greenish color. Okay. William Nicholson in 1753 to 1815, a British chemist, had proved by his experiment that if electrodes connected to the terminals of a battery were immersed in water and the current was passed through the water, bubbles of oxygen and hydrogen were produced. Okay, so the first activity that we did, that if electric current passes through the current water, it produces hydrogen and oxygen gases. Oxygen bubbles were produced on the electrode which was connected to the positive terminal of the battery. Hydrogen bubbles were produced on the electrode connected to the negative terminal of the battery. Keeping this one in mind, what it is saying, that oxygen bubbles were produced in the electrode which is connected to the positive terminal. Nearby the positive terminal, oxygen will produce and negative hydrogen will produce. Now, let us go there again. Now, this is what we were discussing earlier. So, okay, fine. So this is the positive terminal of the battery, and these bubbles here, these bubbles will be oxygen. Here, oxygen gas will be produced. This is negative terminal of the battery. This is negative terminal. So here in this region, in this vicinity, in this area, hydrogen gas will be produced. Okay. So this is what he found out. Now there are some applications of the chemical effect. Now here we saw what is chemical effect, how it occurs and all that. Now what are the applications of it? One of the use of chemical effect of electric current is electroplating. This is very important term, electroplating. Okay. Electroplating. Let us perform an activity to study the chemical effect of electric current. So here you can see that so application of the chemical effect. One of the use of chemical effect of electric current is electroplating. This is very important. Let us perform an activity to study the chemical effect of electric current. This is activity 9. What is the aim of this activity? To study the chemical effect of electric current. Okay, what are the material required? Water, this is water. Copper sulfate crystals, which are kept inside it. Iron rod, this one is iron or iron nail. A copper rod, this is a copper rod, this is a glass jar on which water is being poured. Procedure, these are the two battery. Okay, this is one battery cell, this is another battery, they are connected in series. Okay. Take some water in a glass jar, this is a glass jar, you need to pour some water, then keep iron nail and copper wire here. Attach copper wire with the positive terminal of the battery and iron nail with the negative terminal of the battery. Okay. Now before this one you need to clean them with the sandpaper, because if there are some impurities that will rust present here, they will come up. Now pass current in the circuit by closing the switches. Now after this one, where you need to let the current pass through the whole system. Think how this happen. So now what are the conclusion of it? Means when you do the experiment, what will happen? When electric current is passed through copper sulfate solution, it gets decomposed into copper and sulfate solution. So when electric current passes through copper sulfate solution, the copper becomes one part and sulfate becomes and sulfate ion will produced. Okay. So after some times you will see that the portion of the iron rod dipped in the copper sulfate solution gets coated with a layer of copper. Okay. So here after some time what you are going to see that the iron which is dipped in the solution, from here copper will start and depositing here. After some time you will see that the portion of the iron rod dipped in the copper sulfate solution gets coated with a layer of copper. Now here what you see that this is an iron rod. Here a layer of copper will be deposited. Okay. So think how this happens. So how this happens? When electric current passes through the copper sulfate solution, it gets decomposed. This is a copper sulfate solution. When the electric current passes through it, it gets decomposed, means copper, and it produces copper sulfate, and copper sulfate becomes copper and sulfate. This copper will attracted to the iron nail and it makes a layer on it. The positively charged copper ion moves towards the nail, which is connected to negative terminal of the battery. Now you see this one. This is copper rod and this is iron object. Now here electroplating means what is present in the negative terminal, we are transferring a layer of this same object to this positive terminal. That means here from this copper sulfate solution, copper will be deposited over here. Okay, not copper will come from this one. Okay, sorry, this is the copper rod, this is the iron object. So from here the copper will start depositing here. Okay, copper will start depositing on the iron pot. So the positively charged copper ion moves towards the nail, which is connected to negative terminal of the battery. Thus copper gets deposited on the iron nail. On the other hand, negative sulfate ion move towards copper rod, which connect to positive terminal of the battery. Okay, that means here the copper sulfate solution which conducts electric current is called electrolyte. Electrolyte is something through which electric current can pass. We have already discussed this one. The iron nail which is connected to negative terminal of the battery is called cathode. Cathode iron nail we have already discussed. The process of coating iron or the process of coating of rod or iron with a layer of copper is called electroplating. Okay. So it can be used in chromium coating, silver coating, gold coating, ornaments, utensils, and all that. There are many more uses. Thus, a flower vase made of iron can easily be electroplated. The process is called electrolysis. This is another example. Here you can see this is copper wire, and this is a razor, stainless steel blade where electroplating can be done. The method of putting one metal over another metal with the help of electrolysis is called electroplating. This is the definition of electroplating. Don't write that coating copper on iron is electroplating. This is the actual definition. So you are coating a metal over another metal. Thus, this is usually done to make the object more attractive to prevent it from rusting. Electroplating is used on large scale in industry. For example, steel is electroplated with tin. Okay, and tin is in inert metal and so is less reactive to the iron. Cutlery Silver cutlery is usually made in brass, which is less expensive. Some of the examples are given here, like kitchen gas burner and all that. Now, some ornaments are made of less expensive. These are also some examples are given here. Okay, in jewelry industry also it is used. Okay. So this is all about this chapter. If you have any doubt, then ask me. Thank you all and have a nice day.